A tri-state buffer, or anything that works in a tri-state, isn't just on or off. It's actually got three states. When it's high, it's as if you're hooked to the positive 5. When you're low, it's as if you're hooked up to ground. When you're neither high nor low, when you're undefined, the pin's an open circuit. It's not connect to ground or to plus 5. So you've actually got three states. Plus, ground, open. In a video about electronics for Arduino, which I went over some remedial electronics to help people with the Arduino, I briefly mentioned tri-state buffers, tri-state outputs, and gave a real brief explanation on it. I'm doing this video to demonstrate it a little bit more, how you can actually use that. And in this video I'm going to control two LEDs with one pin. I'll be able to turn on one LED or the other, or turn them both off. The only thing I can't do is turn them both on. Actually, I could turn them both on by turning them both on one at a time at a real fast rate. Your eye would look like they were both on. So I actually could turn them both on with that method, but basically I'm going to, for my purposes right now, one on, and then both off. The tri-state output, or a tri-state buffer, works on being connected to the plus 5, or connected to the ground, or being open. So this pin, right now I'm going to use pin 2 for this example. I can have it open, I can have it grounded, so this LED lights up because it goes from plus 5 through this LED to ground. Or I can have it hot, so plus 5 here lights this LED down to ground, which is what you normally would do. In like the blink example, you turn on a pin high and it lights up an LED. So I've taken the blink example and shown you that the low part of the blink example can also light an LED up. And then I've popped out of write mode completely to turn them both off. And that's all that my modified blink program is going to do. I'll show you that in just a second. The thing you have to note about this, though, is neither one of these LEDs can be a red LED. They both have to be an LED with more than a, like a 3.2 or so voltage drop on them. It's got to be more than a 2 volt voltage drop. So you can't use red LEDs for this. You have to use, white, blue, green, probably yellow would work. For my example, I used a green and a white just because that's what I had handy. And the green will go on when this pin is high and lights us up the normal way. It'll light up white for a longer period of time when this pin goes low. And neither one will light up when I make this pin isolated, when I shut this pin off for write mode. So there's also a related subject called Charlie plexing, which you can look up. There's at least a few good YouTubes on that. But Charlie plexing is a real neat way to do it. See, the reason these LEDs don't both light up at once, and the reason you can't use red, is there's just not enough voltage drop. 5 volts, so if both these have a 3.2 characteristic voltage drop that they want to see, I don't have enough voltage to light them up. If I use two reds, I would. 2.2 plus 2.2, 5 volts, they'd light up. But with two LEDs that have roughly a 3.2 volt drop that they want to see, there's just not enough voltage between the two of them to light them up. So they both stay off, or they light up actually very, very dimly if you look at it real carefully. Charlie plexing uses this method in a matrix, and so I'm using it to light up one LED or the other, two LEDs from one pin. Charlie plexing extends this to a matrix where you'd have a whole matrix of LEDs, and you can, in a bigger matrix, and you can control 7-segment displays and stuff like that with fewer wires than you normally would with a normal matrix. So it's kind of a real interesting way of doing things. It gets kind of complicated though if you're going to light up a 7-segment matrix using Charlie plexing. You can save wires, but you need a more complex program to drive it. Keep, tabs on what's going to be positive and negative and when and where, what pins where. So you can do it with fewer pins, but you'll need a little more complex program to do Charlie plexing. So this is like the rudiments of Charlie plexing, and then I'm just showing you one pin doing 3 different modes, basically. As usual, you want to go full screen to see these right. This is the program I use to blink 2 LEDs with 1 pin. This is basically the blink program. I've pulled out the pin mode statement, which they had in the void setup loop. I turn on the green LED the same way the blink program normally would have turned on the green LED, but I'm also lighting a white LED off the low. So let me go through the program real quick. I do my int. I'm using pin 2 for my LED pin. LED's pin in this case. I've gotten rid of my void setup loop completely. It's just empty. So my void loop, I've moved the pin mode statement that was in my void setup into my loop statement. You'll see why in a minute. And that configures that pin 2 as an output pin. Now I'm writing to that output pin with a high. And then I have a delay for half a second to keep it high for half a second before I go to the next statement, which is going to write it to a low. Digital write pin 2 to a low. And I keep that on for a second. And then to get out of the whole write mode, I dropped it into input mode just to get me out of write mode. And then I've got a delay for 2.5 seconds. And this is how I turn that pin off. This will make things out of focus, but here's my LEDs. Green stays on for half a second, white stays on for a full second, now 2.5 seconds of nothing. So I'm controlling 2 pins, I'm controlling 2 LEDs rather, with 1 output. Another thing cool about this 2 LED setup I showed you, where I've got 2 LEDs in series with not enough voltage to light them up unless the middle pin goes high or low, is I can detach this from my circuit board now. I can actually use this as a probe. I can probe different pins and see if they're high or low. So here's my high, lights up green. Here's a low. And if it was a disconnected pin, it would show me nothing. So I can actually see which of the 3 states the pins are in by using this as a probe and going around and probing my chips.